Hey friends, let's take a moment and thank our sponsors because they make this podcast possible. Let's talk about a new sponsor, Revelo. Having a hard time hiring engineers? Revelo lets you sidestep the competitive U.S. talent market by helping you find and hire skilled remote engineers in Latin America. They only provide full-time senior engineers with over 5 years of experience, and they don't force you to pay for things you don't need, like a project manager. They charge a monthly fee, and you know exactly how much you're paying the engineers. They do the sourcing, they do the vetting, and you can interview the engineers before deciding. They'll manage all the paperwork, including benefits, payroll, and local compliance. And the time zone alignment is a huge win for U.S.-based teams, and it makes synchronous collaboration easy. Questions are answered quickly and effectively. To learn more, go to revelo.com/Hanselminutes. That's revelo.com/Hanselminutes. And as a special limited time bonus, you can mention Hanselminutes and you'll get 20% off the first 3 months. That's revelo.com/Hanselminutes. Hi, I'm Scott Hanselman, and it's another episode of Hansel Minutes. Today, I'm speaking with Sam Aaron. He's the creator and maintainer of Sonic Pi and a live coding DJ. How are you, sir?
I'm very well, thank you much. Thank you so much for having me.
So Sonic Pi is the stuff of legends. You can go and check it out at sonic-pi.net. It's included with Raspberry Pis. It works everywhere. And if you search around for Sonic Pi, you'll find lots and lots of people doing live DJ sessions with dancers and people, entire events being run entirely on this application. What existed before Sonic Pi? How did people do algorithmic composition before this existed?
That's a very good question. I mean, how far back do you want to go? I mean, music itself is algorithmic by its very nature, and certainly even anything that's pattern-based, like weaving, for example, algorithmic, and these things are very intertwined. And even if you look at Ada Lovelace, when she was working with Babbage, and she was able to envisage that these machines they were working on could be much more abstract and more generic machines than the sort of simple computation that they were working on. And she envisaged that these things could make music beyond your wildest dreams, like music that you could dream of. So, I mean, it depends how far back you want to go. And even in the 50s, people were using those huge computers that one city would have, say, and doing interesting things by making them generate music like Baa Baa Black Sheep or something. So I think music and computing has been very intertwined. So I don't think that I'm not going to say anything I'm doing is new at all. But in terms of like more live codey algorithmic things, that's been driven by the ability for computers to have live interactive prompts, and more recently for the music aspect to be able to be generated in real time, which obviously from my perspective, and perhaps yours, it's obviously not possible for all the time in terms of the kind of computers you can buy and have at home.
So really, it seems like it's the accessibility, it's the ease of simply downloading an application and starting, because certainly in the early 80s, we had the rise of MIDI, the musical digital interface. We had SID chips in the early 80s on Commodores, but I wouldn't say that was necessarily falling off a log easy to get into music.
No, absolutely. And I mean, obviously, perhaps a more appropriate answer to your question, I was really trying to sort of embed it in the history, is that there is a tons of really cool live coding and computer music software and applications available today. And there's a whole history of those. Of course, Sonic Pi brings in all the ideas that I find interesting, just as like a language designer might invent a new programming language, but then take ideas from other languages they like. I've kind of done the same. And so there's one of the critical pieces of software that Sonic Pi builds on. It's a really cool piece of software called Super Collider, which is an open source synthesis engine, kind of like Nginx, but for music instead of serving web pages. So yeah, so there's this real rich and growing, and so there's you described these scenes of night events where people are performing with laptops or writing code, and it's projected on the walls with lasers. And obviously, Sonic Pi can do that, and people are using that. But there's a whole ton of other pieces of software which are really cool that people are using and taking advantage of.
That's a great point and a good shout out that there are lots of at varying levels, whether it be the engine level, the UI level, and up and down of things like.
But yeah, I think you're right. Sonic Pi really, the mission of Sonic Pi, its goal is to try and lower the barrier to entry for creative experiences with code. And that's been really one of the core parts of my mission. So although it might be nice to explore new synthesis approaches or new ways to create new interesting sort of compositional abstractions, they can be interesting, but really if they require like a PhD in music theory or something like this, then that might be a really high barrier to entry, but obviously still not, it's still definitely a worthwhile research topic and something to be explored. But Sonic Pi's goal really is to try and make something that anybody can pick up, and anybody, even if they can't code, can pick up and play with, and both learn how to program and learn how to make music at the same time whilst having fun.
And that actually brings up a really interesting question, which is that, you do live sets. We've seen people online doing extremely advanced live sets. I would say absolutely professional, elite musician type stuff. But then we could have a 9-year-old on a Raspberry Pi using the same tool. Do you have any challenges in trying to make a tool that is both accessible to a less than single-digit-year-old child, and a pro at the same time? It's one piece of software.
So that's, when you talk about it in the context of software, which is obviously where we are right now, I'm assuming most people listening are programmers or interested in programming in some way. I think that, the question is quite interesting. It's like, how can you possibly do both? How can you possibly build something which is suitable for professionals, but also something really, really trivially simple to get started? But if you look at it from the perspective of music, it's not actually so complicated, because what is a guitar? That's an instrument that anybody can pick up and anybody can pluck the strings of and make a chord, even if it's just the open strings. Or anybody can look at a piano and play notes on the piano, play all the notes, in fact, all the low notes and the high notes, simply by pressing the keys. So the accessibility of those instruments is really, really low. Anybody can really get started. But of course, you can still have professional guitarists and you have professional pianists. And in fact, I think actually that's really the crucial part of why I think Sonic Pi, at least the goal of Sonic Pi, what I'm focusing on is that nobody really picks up a guitar because it's a beautiful object or because they're interested in the science of it. Although obviously there'll be some super guitar geeks that do that. But most people pick it up because they've seen Jimi Hendrix or they've seen Taylor Swift. And they're like, what is that wooden object they've got? Oh, it's a guitar. I'm going to learn that. And so I wanted to build something like that for code, where you'd have the ability to have motivational figures. So these people performing in nightclubs, when people go and see them perform, they're actually seeing professional programmers in action, and probably more realistic programming than they'll ever see on any TV or movie, where, we've all seen the spinning cubes and the Matrix, and I guess it's really cringeworthy how unrealistic the programming is in typical movies. But this might seem like a far-fetched scene, but actually these are people who are actually live coding on a stage in front of their audience, and showing that code is not just a tool for business, which of course it is, but it's a really powerful tool for human expression.
That was a really fun and interesting bit of a reset in what you just said there, because I felt quite clever in asking my question. I thought that was a good juxtaposition, but you were just like, well, it's an instrument. And in doing that, it made me think about why do we have pro editions of this and kids editions and free editions in this context? There's a guitar, there's a flute, there's Sonic Pi. These are all things that you can potentially use to make music. But it got me thinking about some of the more obscure corners of music. And back on Hansel Minutes episode 447. Folks who are listening can always go hanselminutes.com/447. I had the musician Moldover on, and Moldover is big into this concept of musical controllerism, using musical software controllers to, the mix and scratch and remix music and stuff like that. He's making sliders and buttons and totally custom stuff. And I know that you have similar things in your space. Those aren't just guitars and flutes. That's creating controllers that are advanced and custom. But I haven't seen Sonic Pi go pro, I guess, is my kind of question underneath that. Can you plug into controllers, and do you have MIDI interfaces to combine those two concepts?
Absolutely, yes. So Sonic Pi is full I/O capability with MIDI. So any MIDI device, so any MIDI keyboards, and pretty much all these off-the-shelf devices have some sort of USB MIDI plug-in, or old school like dim switch. So you can plug that right in, and it'll automatically detect it. And if you can even press keys on the keyboard, and the events will stream on the screen without you even having to write a single line of code. Of course, if you wanted to do something when you press that key, other than just show that the key was pressed. You do have to write a code, but that's interesting because you get to choose what it does. It doesn't have to actually, if you press the middle C on a piano, you can obviously program it to play a middle C if you wanted to, but you don't have to. And you can choose what you want. And similarly for the slider or the button, you can choose the actions and what those do. And Sonic Pi does MIDI. It does open sound control, which is a network protocol. So it can send and receive messages between other devices, whether that might be other Sonic Pis running on your network, or maybe you have a VJ app that receives open sound control. You have TouchOS, which is one of these controllerism apps that people use, which has, like, if you've got an iPad or any touchscreen device, you can make your own UI, dragging and dropping the buttons, and they will send these open sound control messages. And then obviously you have to tell Sonic Pi what that means. And then in addition to that, and just recently, we've just released a version which includes something called Ableton Link, which is open source technology that allows compatible apps that have this link technology built in to synchronize their beats, their tempo, and their beat phase, which basically is all fancy words for it sounds in time with each other. And when one person makes the tempo go up, they all go up in synchronization. So without having to write a single line of code, you can just actually start Sonic Pi on multiple computers on the same local network, and they'll all be playing in time with each other automatically, which is huge fun. So although I agree that there isn't yet lots of use cases where Sonic Pi is used by more professional musicians, I think that the potential is there. And of course, a lot of these like existing professional artists have all got their own workflows, they've all got their own setups. So integrating something new and pretty alien like Sonic Pi is always going to be a hard sell. But I think there's going to be a whole ton of new growing talents, and I'm seeing examples of this already, where people are taking advantage and seeing it as normal to program their music rather than a weird alien concept. And can I just your question before about the music instrument being a simple interface versus a complex one at the same time? Actually, I think there is a sneaky aspect to that, which kind of I kind of didn't really go into too much detail, but I think is really important, which is traditional instruments don't just exist out of nowhere. They've evolved over many hundreds of years of complete modification and iteration, and so although we see these orchestra instruments, for example, like the piano or the flute, as static fixed designs, that they are pretty static today, but they certainly evolved radically over the period of time. So although they are both simple and hard, I think that's also a process of a lot of design, a lot of iteration, a lot of usage, a lot of learning how to teach with it and not with it. And so I think the answer to your question about why does software have a pro mode or not? I think the real answer is that probably that people haven't thought about the design enough. So what's made Sonic Pi possible to teach to children and also be something suitable for professionals, at least the way I'm approaching that, is thinking about it really deeply and not just throwing features in that a professional will ask for. A professional will ask for a whole feature set. It's never to do that. It's to actually think about how can I put this into the system in a way that actually fits in, that works nicely, that I could teach to a 10-year-old child. And so a feature doesn't go into Sonic Pi unless I've actually gone through that process and got an implementation of it that I'm happy to sit down with a 10-year-old child and show them. And so that's really, I think that's a critical difference, is that lot of iteration and design time that goes into these things to make it both something that's suitable for professional end users and for beginners.
Which really is kind of the essence of accessibility, because if it is accessible to a kid, then it's going to be fantastic for an adult, and it's going to be a natural thing for anyone to pick up. Everyone wins at that lowest common denominator perspective.
It's totally true. And I mean, when I designed features specifically, because Sonic Pi was built for the classroom, I was working with teachers in schools, teaching introductory computer science and using the music as a vehicle to engage the school children with computer science. And so a lot of the initial features built for Sonic Pi were specifically to help that school teacher, child context, that setting. And so there's a whole bunch of things about making error messages, for example, easier to read and understand, and where things go wrong, to try and find ways to actually make that easier to resolve, because all this stuff is critical time in the classroom, and teachers typically have very little time. But surprised me, it turned out a lot of these ideas were really beneficial to me at 2 a.m. in the morning after I've had a couple of beers and I'm about to perform in a nightclub. And actually, like there's a remarkable number of similarities. Like, oh, I'm really pleased I did that feature because now, well, obviously, when something goes wrong in a nightclub, you don't want to spend 10 minutes debugging it. You need to be able to like super quick fix it. And so that's exactly the same as in the classroom, where the teacher wants to be able to resolve the school child's issue and move on to the next pupil. So I completely agree that accessibility. That's what I'm trying to say. Is it completely surprised me that a number of features I added specifically for the classroom worked really well. And so that became like part of my design philosophy is to, by focusing on that school environment and on that 10-year-old child learning, all these other extra features just became really powerful and useful in other ways I hadn't actually imagined initially.
Hey friends, this is Scott. I hope you're enjoying this chat, but we are going to take a brief break and we're going to have a chat with our sponsor. Our sponsor, Raygun, today makes shows like this possible. You know, JD from Raygun, I've got Hanselman.com, I got HanselMinutes.com, the Hanselman International, right? It's a big, giant, super corporation, right? No, it's one person. It's me and a couple websites in Azure. And I thought I was doing well when I got them all to build and deploy successfully. But I wasn't thinking at all about runtime. But then I plugged in Raygun, and suddenly I'm finding out specific users that are having specific issues about stuff I'd never even thought about. Why do people focus so much on the build time of DevOps and then they forget about the runtime error reporting?
Yeah, I mean, it's a great question. Some folks, frankly, it's a little uncomfortable to see the number of issues that may be in the code base. That's a big contributor.
It makes me feel like I'm double or triple. I don't like the word 10x developer, but what's cool about it is it feels like while I sleep, someone is going through my log files, looking at my call stacks, bucketing them, and I'm being multiplied. Like I'm one person with one website, but I feel like a team of 4 or 5. I've got testers. I've got runtime analysis people. I've got log parsers, but it's really just me and the cloud and Raygun.
Yeah, I always like to think in an ideal situation, I like tools to feel like they're a virtual team member that's just working around the clock, right? Make the computers do the work. That's what I'm trying to build with Raygun.
I love that. Let computers do the work. That's exactly what it feels like. Like I used to live in fear of my websites. I was afraid that I was coding them poorly. I was afraid that they were going to fall over. And now I have tools. I have DevOps both at the build time and at the runtime. I've got error reporting, crash monitoring, performance monitoring while I sleep. And I can wake up and I can see bucketed lists of what's going on my website. I can choose to ignore some and I can prioritize the other ones. And folks who are listening can do the same. You can go to raygun.com, sign up for a trial, and you'll have this superpower in like a couple hours. That's like, it takes no time to set this up. Could you explain your relationship to academia? Like, what is your background? Did you start studying this and it became a passion? Were you a musician first and academic second? Because you're talking about doing actual thoughtful research. And I know you had a relationship with the University of Cambridge Computer Laboratory. If I were just making a piece of software myself, I don't know if I would have had the clarity of thought to go and have the formality of actual research. I'd probably just guess. But there seems to be a lot more structure to what you're doing here.
Possibly. I mean, it's mostly guessing, to be honest. I guess that a lot of it is also to do with finding the right people to ask the right questions to, listening to them. And I do get asked the question an awful lot, actually, when I go to conferences of, were you a musician first or a programmer first? And I often retort and ask them which domain they're programming in. And they're like, banking. I'm like, were you an expert in banking first or a programmer first? Whatever domain they're in. Were you an expert in sports or pharmaceutical industry or whichever domain you're news or whatever? And they like look at me like strangely, but it's like, why is it any different with music? And so it isn't. And so all I've done is I've applied the way I approach programming in any context, any industry context, or any, we can talk about academia in a moment, but just in terms of learning the domain and applying that knowledge to what I'm doing. And that's no different. But in terms of academia, I did a degree in computer science. That was where I was interested in school, but there wasn't really much computer science at school when I was there. But I did play around with the graphical calculator an awful lot and taught it to make fun games and Pac-Man and Tetris and little tanks and things. And so I decided that programming was for me. And then went to university, and then I did a PhD in computer science, and that was predominantly on touching around language design and domain-specific languages. And then I went to industry, worked there, but I applied those ideas and I built like mini programming languages to describe the business logic and the way that the client could read. That was super useful because the project was super complicated and the client kept coming with new ideas every week, and it never stayed constant. So I built a language that could actually move in the same pace that his thinking was. And then I guess the tipping point going to music was I was at a conference in Denmark, and it was a technology conference. And then in the evening there was a party, and they basically found all the programmers that could play instruments and made a band out of them, which is a fun idea, but it was a bit awkward. And it was obviously they could have practiced a bit more. But also I was thinking, well, why aren't they programming the music? Surely that's possible. And then that I thought that was obviously wouldn't be too hard. And like whatever, 15 years later, I'm still trying to learn how to do it myself. But I've come a long way.
Well, one of the things that I admire about what you do is that you're applying a formal pedagogy, a formal sense of how one learns and how people learn to this idea. And what makes Sonic Pi, and correct me if I'm wrong, so exciting for early in career or young programmers is the liveness of it. When I teach someone Hello World, it's like type a bunch of stuff with no feedback, press F5 or compile and run, and then you get Hello World. Yay, now stop and code in silence with no sense of liveness. There's something about the liveness of Sonic Pi. Have you found that really makes computer learners light up?
Yeah, I mean, I think that's really part of what helps people find that sort of flow state, which engages them more. But when I first worked on it, I mean, actually, in terms of the academia part, I mean, I went to industry, then went back to do the music things. I was working on a project called Overtone, which is a Clojure-based environment for live coding music. So that was my attempt to answer that question about the conference. And then I found myself in the computer labs at Cambridge randomly. And I had a little desk there. They were interested in what I was doing.
Mm-hmm. So the sense of understanding of that liveness in a computer environment is so much more engaging, and that it encourages collaboration, it encourages flow state, and it gets people more creative. And I would hope that it would cast a wider net to people who don't necessarily have the ability to code in silence for hours before they get the payoff. Sonic Pi gives a payoff constantly.
Yes, I agree. And what I found really interesting was that when I first wrote the first version of Sonic Pi, that was as a postdoc project at the computer labs at Cambridge, it was specifically to target the computer science new curriculum in the schools. And so that was my specific focus. And so none of this liveness you're describing was part of that at all. Because if you look at the computer science curriculum for schools, it's about algorithms, about data structures, conditionals, variables, the kind of the standard kind of things you might expect to see on a quite a dry, sensible curriculum where everyone tried to sit in a room and figure out what are the important things to teach. But obviously, any ideas I had about doing something interesting and more musical or more flow-based, like you're describing, of course, they were superfluous and they were not part of the initial project, which was a very, very short-termed, very specific strategic project. But of course, in the classroom, the kids kept asking really interesting questions about how do I do this interesting music thing? How do I do this? How do I do that? And so the answers were always like, I'm sorry, you can't. It's not on the curriculum. I'm sorry, you can't. It's not on the curriculum. So I found ways to actually slip in these ideas into the program that the teachers weren't really aware of. So they were still teaching their things on the list that they had to teach, the sort of algorithms and data structures and loops and things. But I was sticking in concurrency, because obviously playing multiple sounds at the same time is actually pretty useful in music. Having a bass line at the same time as a drum beat is pretty useful in music. And the kids were asking for this. They were asking, how do I play the drums at the same time as the bass? And like the answer was, nope, can't do that. I'm sorry. You've got to wait till you're 18. And when you're 18, then you can go to university and they'll teach it to you there. And so actually a lot of these interesting things you described, which were added by me as a way to improve the engagement to the kids. And of course, then at some point I started using it myself and I became the main user, and I was adding features that I thought were engaging and useful for me for performance. But of course, in a way that didn't interfere with that pedagogy, that learning experience, making it simple. I was always using my experience to think about how this idea I've got, super cool, and it'd be really nice for me, but can that 10-year-old child use it? And that turned into this, what you're describing, this really nice environment where people really can write some code, get it started, modify it as it's running, and hear those differences immediately. And that really provides a really fabulous, I think, engaging experience. But that's not just a fun for learning. That's actually the experience which is required if you want to do a performance. And so actually those two things work really well together.
So to paint the picture for folks, you're inside of Sonic Pi, and it's kind of a digital notepad. You've got waveforms and things appearing. You've got tutorials, examples at one side. You've got FXs, synths, and samples. But for the largest part, you basically have, what is is it Ruby code proper, or is it a DSL, a domain-specific language of Ruby that we're looking at?
Yeah, it's the latter. It's a domain-specific language which I've written currently in Ruby, but there's plans to port it to Elixir. It was there because I needed to build something in 2 weeks, and I had professional experience with Ruby, and so I knew I could get the basics of a little language which you use to start to teach the kids these computer science concepts. But that's only a small. I mean, that might look like the main focus, but Sonic Pi actually has multiple things happening at the same time, and one of them is that DSL. But that DSL really just is a declarative, essentially description. Although it's in Ruby, it's very functional. It's actually the semantics, execution semantics, are much more like Erlang. And because just the way of building the system to make it interesting from a musical perspective turned out to take me in that direction. But yeah, it is in Ruby. But yeah, it's more like a weird. If you look at the source code, it's like a Clojure person who used to know Ruby, trying to take idioms from there, and then try to build like a really bad implementation of the beam. It's a mess.
But to your credit, though, it still is quite fluent. Like it doesn't. It may look like all of those things if you know all of those languages, but as someone who's just sitting down and go, yeah, 4.times do this thing, use synth, play chord, sleep. It's quite digestible.
Yeah, well, that was a goal to be able to have somebody who was a computer science teacher, which means that they probably don't actually have a degree in computer science often, and they certainly won't have any music background knowledge. So to have something anybody can approach and work with, and similarly when you're watching someone perform, like it's really often these performers will project their code so you can see what they're using, and that is an opportunity to either look super cool like the Matrix and have all this stuff that's flashing around and looks amazing, or to have an opportunity to have a description of what's happening. So interested people can look at it and read and understand the performance and get inside of what's happening. And we talked earlier about different live coding systems. Some take the former approach of trying to look like something out of the Matrix, which is amazing. But Sonic Pi really tries to invite everybody to have a go at understanding what's happening and tries to be as welcoming as possible, really.
Now, when you're doing this live, you've got code that quote unquote compiles, it's syntax correct, and you hit run. If you make a mistake, how does it not suddenly sound bad? Can you explain that relationship of it doesn't ever go wah.
Well, it certainly can, right? So, the kids do this, right? There's the early days. People would make a synthesizer, make a beep, and then you show them the amplitude option so they can change how loud it is. You can say like beep at half, it's a bit quiet, and a beat at 2 is really loud. So, of course, they do beep 2 million trillion, and then their ears start to bleed. So, I did add a safety system in to add a compressor at the end to reduce that from causing any issues. But really the side is that you can put weird parameters in and get strange sounds. And when I've been working with the system, whenever that's happened for me, I've added a sort of a safety system which looks at the parameters and sees if they're the ones which I know are going to be bad and throw an error and say, please don't do that. You can turn this off if you want to, because there might be some really interesting sounds to be found, but that's at your own risk. So yes, that goes on. But
you do try to make it not hurt, though.
Yeah, it definitely doesn't hurt. So there's a safety system built in, which is a critical thing, which SuperCollider didn't have, but actually they've now added a similar thing in a recent version. But in terms of your description, you can write your code. If it's not syntactically valid, obviously it just throws an error and says I don't understand, and then you can fix that. But if it's already running and you have a runtime error, so you might make a mistake which the computer can read, but when it tries to do it, it doesn't make any sense to it. What happens there is that program will stop. Now, if you if you just got one thing running, that thing will just stop, and if you're doing a performance, there'll be no sounds, and that's no fun for anybody. So, what Sonic Pi really sort of encourages is sort of like a dependability aspect or a reliability aspect, where you can actually run multiple threads, so multiple musicians almost playing in a band at the same time. So you can have a thread that's the drummer, and a thread which is the bassist, and a thread which is playing the melody. And If you introduce errors in all three at the same time, then all three will stop. But if you introduce error in just one of them, that one will stop, but the other two will still be running, or whichever ones which are still running will still run. So you can isolate the errors to a thread, which really makes it nice to be able to work with, because actually often I performed and I've done exactly this, because you can't help but typos and things.
Of course.
You press a run and it makes a mistake, and then the audience go, yeah, the musicians brought the music down to like just a kick drum, like, oh, I'm fixing it frantically. But this raises, I think, important questions, actually. So it's not just important to be able to say, can we survive a crash? Like obviously, if the whole system goes down, then we can't survive that. But we can try and isolate the problems as quick as possible, and can we recover from them? And so the recovery is also actually really interesting to talk about, because typically the recovery is for typical programmers is bring everything down, bring it back up again,
right?
Reboot. Right, reboot to whatever level you need to reboot, and typically that's reboot the program. So when you see tests or you're doing some test work, you'll clear a database, you'll fill it with some mock stuff, you run your tests, and then you'll clear the database, fill it with the mock stuff, and run your tests, and you're always tearing things down and bring things back up again. And that's fine if stopping for a moment is acceptable in what you're doing, which typically for programming, certainly for development work, it is. We're always stopping and starting and stopping and starting. But in music, when you're performing, definitely not cool. Just like, sorry, everyone, I've just got to stop the code, fix the bug, start the code again. Like, it's not going to work. So being able to recover from mistakes whilst the code's running and bringing threads back online again, but not just running at the same time, which obviously is what concurrency typically offers you. It says this thread and this thread are running at the same time. Now, whether if they're operating system threads, they're likely to be running on different CPUs at the same time. But some programming languages sort of emulate this and pretend they're happening at the same time, which is what Sonic Pi is doing. But yeah, they are operating at the same time. And so, but then what they're not doing necessarily is working in time. And that's what you want with a band. You don't just want the guitarist to play at the same time as the drummer, but not caring about each other or looking at each other and looking and wait 3, 2, 1.
I wouldn't want the entrance of the guitar to be like dependent on my ability to press the button on tempo. I would like it to
that's another extra. Yeah, absolutely.
Right in and know, like, hey, we're all at 3/4 right now. Let's just keep, I don't want to make a mistake. Like, I clicked too slow and I messed up the whole rave.
Totally. So you want to be able to bring things in and have them synchronize temporally, so be in time with existing things. So there was a bunch of like interesting work I did that I hadn't seen anywhere else. So I just had to solve. And so, for example, in concurrency, you have a concept called thread barrier synchronization, where you have multiple threads and you want them to talk to each other. And one thread says, "Have you done your stuff first? And if you have, then I can carry on my things." So, like if you're packing a cart from a truck and you're taking the apples from the truck into a cart, and someone's taking the apples from the cart into a basket, maybe you want to wait for the cart to be full before the basket person does their work. And so there's communication saying, "Are you ready? Yes, I'm ready. Let's carry on." And that's how threads can coordinate. I'm being very woolly there, but what I do is I do that, but I also can pass the idea of a time, so that when one thread waits for its turn, when it is its turn, it gets the time from the thread that started it, so that it can then start in time with it. It's all technical nonsense, but really, what you can do is you can start a thread and have it synchronized with any event,
right?
And be precise with that event. And a critical thing here is this idea of a live loop in Sonic Pi, which is sort of the fundamental construct for concurrency, which is synonymous with the idea of a band member. So a live loop is like the guitarist or the drummer.
Right.
When they spin round, so loops just go round and round and round. Every time it goes round, it sends an event to the system saying, "Hey, I've gone round. I've done my thing, and I'm going to do it again now. Done my thing, I'm doing it again now." Every time it sends an event, that's an opportunity to synchronize and to say, when that live loop spins round, I'm going to start myself.
Right.
And then they'll start in time with each other.
And so from a musical perspective, if I were a band leader, I'd be like, okay, on the next phrase, bring it in the downbeat. And then I make some hand gesture and I go, and you're in. And then they come in and we speak that shorthand and we know how to do that. So you have expressed that in code so that you can be your own orchestra.
Yes. I mean, that's just by writing the word sync and then the name of the live loop you want to synchronize with. And that automatically brings up that thread barrier synchronization I was talking about, which waits for the thread to happen and then passes that time across, and then they start up and they actually have the same logical idea of what the time is. So they operate. At that point, they're synchronized. And then they can diverge. One could be going faster, the other one could be going slower. Like, they don't have to have the same tempo, but at that point of synchronization, they both have the same time.
Brilliant, brilliant. So folks who are listening, you can pick up Sonic Pi at sonic-pi.net. You can get it anywhere. You can certainly search for it and find it easily. You can get it on Windows, on Mac. It's on Raspberry Pi OS. It'll work on your biggest, most fancy computer. It'll work on your tiniest Raspberry Pi. It's great for kids. It's great for pros. And of course, if you're a pro musician, whether you're using Open Sound Control or MIDI, you've got that support as well. And then, if I understand correctly, you can be supported on Patreon as well, or GitHub sponsors. So if you love Sonic Pi, and it took this podcast for you to appreciate Sam and his work so much, now is the time to support his work on Patreon. This has been great. Thanks for chatting with me today.
You're very welcome. Yes.
All right. This has been another episode of Hansel Minutes, and we'll see you again next week.